our physics class today, we are going to be learning a topic we call measurement involving instruments. This is our part 1A. In this aspect, we are going to be learning the instruments we use in physics and how we use them to measure. Now let's move on to the course outline and see what we have. Coming to the course outline, we are going to be learning types of error, the instruments used for measurement, and the calculation involving measurement. These are the things we are going to learn under this topic. By the way, my name is the Ambassador, and you are welcome to my class. Let's move on to the work for today. The very first thing we are going to learn is types of error. Before we move on to types of error, I want us to understand in physics, no measurement is perfect. No perfection. That means it is believed that there is no calculation that is perfect. It's either there is a slight change in the calculation or there is a slight change in the instrument. So that is why you see in physics, anytime they give a given measurement, they usually add plus or minus 0.5, either centimeter or millimeter or decimeter. Why? Because they will actually try to measure the measurement either by adding 0.5 or subtracting 0.5 because they don't believe in the perfection of the instrument. That is why error in physics is very important. Let's look at the kind of error we can see in physics. There are majorly two kinds of error in physics. We have what we call the systematic error and what we call the random error. What is systematic error? The systematic error is the error caused by instruments, while the other error is error caused by man. Now let's see how they are being caused or how they are being done. Coming down to systematic error. This is the kind of error done or made by an instrument, and a typical example of that is where we have a wrong calibration. For instance, let's assume we have a simple pendulum experiment. What is a simple pendulum experiment? A simple pendulum experiment is a kind of experiment that involves a ball attached to a fixed point with a string, and the ball is oscillated to move to and fro with a reading of a stopwatch to calculate the amount of time needed to complete a specific number of oscillations. For instance, let's assume they want to calculate the number of oscillations it will be needed or the time taken for 10 oscillations. Whenever you want to calculate oscillation is when you move to, then the ball come back, fro. They come back again to, fro. So when the ball moves one, then go back, it's called one oscillation. When you move again one, then go back, it's called two oscillations. I see that. So the time taken for the ball or the body to complete 10 oscillations is what we call period. And most of the time, don't forget, gravity is going to act on the ball. And not only gravity, also going to have air resistance. Gravity and air resistance will act on the body, and they will try to slow down the rate at which the body moves to and fro. So that means we cannot get a perfect measurement of the oscillation of that body, and that is why we call it systematic error, error that is caused by instruments. Now let's move on to the next kind of error. Coming to the next kind of error, which is called random error. What's random error? Like I said, these are errors caused by man. I wrote down here that this is a kind of error caused or done by humanity, and the most common kind of error is called a parallax error. The parallax error is a kind of error that deals with the position of the side. You look at this woman here, she's looking from this side at the middle and the other side, trying to measure the height of a nail. Now, when the woman tries to look from this angle, she's going to measure the height of the nail a little bit lower. Why if she measure from this angle, she's going to measure the height of the nail a little bit higher. But when she measure from the middle side, she's going to give an exact height of the nail from the middle side. So in this kind of issue, anytime she measure from here, which is actually wrong, measure from here, which is actually wrong, that kind of error is called the parallax error. So these are the two major kind of error we have in physics, which are called the systematic error and the random error. Okay, so the next thing we are going to learn is what we call the apparatus used for measurement. We are going to look into some apparatus, or let me say the instruments used in physics to measure. Now, basically, like I wrote here, there are basically many instruments used in physics, but we are going to be focusing on some, not all. And the one we are focusing for our own class is just mass, the length, and the time. The instrument used to measure mass of a substance, to measure the length of a substance, and likewise to measure the time of a substance. Like I said, we have other measurements that is used to measure. For instance, let's look at this carefully. If you look at this carefully, you see we have a thermometer. A thermometer is actually used to measure temperature. You see we have a voltmeter to measure volt, an ammeter to measure current, a galvanometer to measure volt also, and other kind of measurement. As you can see here is a cathode ray oscillator. So these measurements you are seeing are meant to measure a particular kind of substance or a particular kind of quantity. But focusing for our exam purpose, we are going to be considering our mass, length, and time. That means the instrument used in measuring mass, length, and time. Now let's pick it one after the other. Coming with the very first one, which is our mass. Have it in mind that mass refers to the content of a body, not the weight of the body. Mass refers to the content of a body, not the weight, because mass determines how much a substance is, not how heavy a substance is. So that's why I wrote here, it is used to measure the content of a body, and we have different instruments we use to measure mass. But before I go on, let us see the difference between mass and weight. Anytime we have mass, firstly, mass is for the content, while weight is for the heaviness. Another thing again is that our mass is measured in kilogram, while weight is measured in Newton. Another thing is that our mass is constant, while weight varies. So they are very, very different. So you can't say mass is weight, likewise you can't say weight is mass. So we know that mass is to measure the content of a body, while weight is to measure the heaviness of a substance due to acceleration to gravity. Now let's move on to the kind of instrument we use in measuring mass. Types of instruments used in measuring mass. There are basically three instruments in measuring mass. The first one is called the beam balance, the other one is called the spring balance, and the third one is called the beam balance, chemical balance, then the third one is called the spring balance. Now we are going to see how these are being used, what are they meant for, and when can we use them. Now let's start with the very first one, the beam balance. The beam balance majorly is likely to measure the mass of a substance. For instance, let's assume I want to measure the mass of a box. When I try to place my box here on this plate, we are going to have a kind of a pool at the side. But because we want to measure the mass, this we are saying will be attached to this side of the beam balance until there is an equilibrium in which there is no one side higher or one side lower before we can say this is the exact mass of the box. So that means if I try to add one of these weights on this my measurement here and I found out that it balanced, I'm going to look at the side that is balanced on the reading. So that side that is balanced on the reading with the box will determine the mass of the box. Another kind of measurement we have is called the chemical beam balance. The chemical beam balance, or literally you can say chemical balance. Now majorly this is mostly used to measure chemicals, as you can see, telling us the amount of mass that are in the chemical. As you can see here, we see that we have a weight and a chemical, which is the conical flask. Now this weight is helping us to balance the weight of the conical flask. So when we see that there's an equilibrium between the mass here and the chemical here, the exact place they are in equilibrium is what we are going to measure at the side. Are you seeing that? Now have it in mind, the chemical beam balance is more accurate than the beam balance itself, due to because it is more graduated and more efficient than the normal beam balance. Let's move on to the other kind of instrument we use to measure mass. The other kind of instrument we use to measure mass is called the spring balance. Now basically, the spring balance majorly works with the weight of a substance. It majorly works with the weight of a substance, not really the mass. Why? Due to because when we try to attach a body on the hook, the body is suspending on air, and as the body is suspending on air, gravity is trying to pull the body downward. As gravity is trying to pull the body downward, it's actually getting the weight of the body, which is mass times gravity. So the weight of the body will be read on the reading on the spring balance. So whatever reading we have from the spring balance, we can be able to get the weight of the body. And also, we can also get the mass of the body. Let's assume we have a body and we know that gravity is pulling the body downward, and literally we're able to get the reading here as 50 Newton. 50 Newton should represent the weight of the body. So I can say W is 50 Newton and I want to get the mass of the body. Recall that gravity is the constant value which gives us 10 meter per second squared. So when I say weight equals to m times g, I'm going to add that the weight equals what my n? My n is what I'm looking for. My gravity is 10, while my weight is given at 50. So I'll say 50 times 50 equals to m times 10. When I try to divide both sides by 10, this cancels out. Then I'm left with what? M equals to 5 kilograms. I've literally gotten the mass of the body. Okay, the next kind of instrument we are going to learn is the instrument we use to measure length. Now, firstly, what is length? Length, this is measured by the gap between 2 points, and it is graduated in meter. I want you to know that many times we make use of distance and also displacement to represent length in physics. And both of them are measured in meter, but one is a scalar quantity The other is a vector quantity. Now let's see the instrument we use whenever we want to measure the length or the distance of a substance. Types of instruments used in measuring the length. There are basically four types of instruments used in measuring length. We are called the meter rule, the caliper, the vernier caliper, and the micrometer screw gauge. The meter rule, the caliper, the vernier caliper, and micrometer screw gauge. Picking the very first one, which is the meter rule. Now, the meter rule is mostly used to measure any form of linear object. Anytime you have a linear object, like now we want to measure the length of a book, or we want to measure length of a phone or your laptop as you are holding it, or we want to measure length of a room. You can make use of the meter rule. Why some people make use of tape rule? Yeah, the meter rule and the tape rule are found in the same gradation or calibration. But now let's see how they use them and what they are measured in. I wrote down here that the meter rule, it is graduated in 1 decimal place in centimeter. For instance, whenever you want to measure the meter rule, the smallest unit is 0.1 centimeter. Or it is graduated with the one that has no decimal place, which is measured in millimeter. For example, 10 millimeter. Now what am I trying to say? What I'm trying to say is that the meter rule contains millimeter or centimeter, and 10 millimeter in the meter rule is equivalent to 0.1 centimeter. That is why they say 10 millimeter make 1 centimeter. Are you seeing that? So that's how it looks like. Let's see what we use it for. The usage of the meter rule. It is used to measure linear length of matter or substance. Like I said, imagine you want to measure the length of your phone or the length of the room. We make use of either tape rule or we make use of your normal ruler. As you can see, we have a diagram here. At this side of the diagram, we see that it starts reading from centimeter, then from centimeter we have 1 down to 15. While at this side we have inch. Yeah, inch is more larger than centimeter. So in the meter rule, that you see millimeter, millimeter is less to centimeter, centimeter is less to inch. So that's the measurement we have in meter rule. Now let's consider the other kind of measurement. Considering the other kind of measurement, which is called the caliper. What do we use the caliper for? The caliper is mostly used to measure cylindrical objects. Cylindrical objects. For instance, imagine I want to measure the length of a round stone. The length of a round stone. For me to measure the length of a round stone, I will have to make use of caliper. And how does the caliper look like? The caliper look like this, in which at this side we have the teeth. The teeth is meant to hold the round stone at the edges. For instance, let us assume we have the round stone at the edges. Now that I've actually measured the round stone at the edges, I'm now going to pick my caliper and place it upon a meter rule. When I place the caliper upon a meter rule, I'll be able to get the length of the stone or the length of the round object. So that means the graduation of my caliper is equivalent to the graduation of my meter rule. What do I mean? It means that the same measurement we use for your normal ruler or your normal tape rule is also the same measurement we use for a caliper. As you can see here, I said it's also graduated in 1 dp in centimeter, which is 0.1 centimeter, and it's also graduated in 10 millimeter, just the way we have it in our normal ruler. So what's the essence of why we have the caliper? It is used to measure cylindrical objects. Example of cylindrical objects: you can have your stone, you can have your ball, you can have an egg, and so forth. Let's consider another instrument we make use of when we are measuring length. The other kind of instrument we make use of when we are measuring length, the other kind of instrument is called the vinyl caliper. Now, the vinyl caliper is just the advanced kind of instrument compared to your caliper. Majorly, the vinyl caliper is used for round objects, just the way we have our normal caliper. But in this case, the vinyl caliper helps us to measure the diameter of the object. Sometimes they call it the internal diameter. That's what we use the vinyl caliper for. Example, let's assume I want to measure the internal diameter of a test tube. A test tube is an apparatus used to hold reagents during experiment. So if you look at the test tube, at the open area here, you can try to get the diameter. So with the help of vinyl caliper, it can help us to measure the diameter of a test tube. So majorly, we make use of the vinyl caliper to measure any internal diameter of any cylindrical object. Now let's consider the gradation on the vinyl caliper. It is also graduated in 2 dp in centimeter. For instance, we make use of it at 0.01 centimeter, and also it is graduated in 1 dp whenever it's converted to millimeter. Please, you must understand that anytime I'm referring to 0.1 millimeter, that means the 0.1 millimeter, if you want us to convert it to centimeter, is equivalent to the 0.01 centimeter. That's the meaning of what we are talking about. So it's either you measure it in millimeter by counting it as 0.1, 0.2, 0.3, or you measure it as centimeter by counting that 0.01, 0.02, 0.03, and so forth. Now let's see the usage of what we talk about the vinyl caliper. It is used to measure internal diameter of an object, like I said, for example, the internal diameter of a test tube. Okay, going on to the diagram, this is where I want everyone to pay attention to. In the vinyl caliper, there are actually 2 kinds of scale. The very first kind of scale is called the main scale, and the other kind of scale is called the vinyl scale. The main scale and the vinyl scale are the 2 kinds of scale we have on the vinyl caliper. Let me show you where we have the main scale. Where we have the main scale is at this area, and when we have, sorry, that's a typographical error. Sorry, that's an error from my hand. Where we have the main scale is at this side, and where we have the vinyl scale is at this side. If you look at this carefully, let me show you. You would have seen that there is a reading that ranges from here to this side. So that reading that ranges from there to that side is called the vinyl scale, which I'm representing as VS. Why the main scale are the one that read from the end to this end? That is the main scale. But for the vernal scale, they read from this end to this end. Now, another thing I would love to tell you is that what is the gradation of the main scale and what is the gradation of the vernal scale. The gradation of the main scale, when I refer to gradation, I mean what is the reading on main scale and likewise what is the reading on vernal scale. The reading on main scale is 0.1 centimeter and on vernal scale is 0.01 centimeter. So please know that. So the reading is 1 decimal place on the main scale, on the vernal scale is 2 decimal place.